Bridge technical condition evaluation calculation includes elements, components, section, whole bridge score calculation. After completing the calculation of the components and elements for bridge technical condition evaluation in the last class. Next, this lesson covers section and whole bridge score calculation. Calculation method details. Article 4 of the Highway Bridge Technical Condition Evaluation Standard. General bridges consist of superstructure, substructure, and bridge deck system. Each location contains corresponding parts. The components and component weights included in different bridge types and parts are detailed in tables 4.21 to 4.24. According to Formula 4.13 of the Highway Bridge Technical Condition Evaluation Standard, score for each location is obtained by summing the product of component score and component weight. For example, a certain bridge is a beam bridge. Its superstructure includes superstructure bearing components, superstructure general components, and bearings. Refer to Table 4.21. The weights of these three parts were obtained as 0.7, 0.18, 0.12. The scores of these three parts were previously calculated as 70, 80, 90 points. Therefore, the superstructure score is 70 multiplied by 0.7 plus 80 multiplied by 0.18 plus 90 multiplied by 0.12 equals 74.2 points. Calculation method for the substructure and bridge deck system. Consistent with the superstructure. When using the above method to calculate the section score, note that in practice, not all parts are equipped with complete components according to tables 4.21 to 4.24. For single-span bridges without piers, some bridges lack sidewalks. At this time, the weight value of the missing part needs to be allocated to other parts. The allocation method adopts the method of assigning missing component weight values according to the proportion of existing component weights in all existing component weights. Method of allocation based on proportion. For example, the bridge deck system includes 6 parts. The sidewalk is one of the components of the bridge deck system. The sum of weights for 6 components is 1. However, a certain highway bridge has no sidewalk. At this time, the weight value of the sidewalk part can be set to 0.1, allocated to the other 5 parts of the bridge deck system. The sum of weight values for the other 5 pieces of components equals 0.4 plus 0.25 plus 0.1 plus 0.1 plus 0.05 equals 0.9. Before allocation, bridge deck pavement weight is 0.4. The allocated weight for bridge deck pavement is 0.44. The overall technical condition score of the bridge adopts the weighted summation method. Superstructure. The substructure accounts for a weight of 0.4, respectively. Bridge deck system accounts for weight 0.2. Section score multiplied by corresponding weight equals the respective section score. The sum of scores from the 3 major components equals the whole bridge score. When the technical condition ratings of the superstructure and substructure are Class 3, the bridge deck system's technical condition rating is Class 4. And when the overall technical condition score of the bridge is 40 is less than or equal to Dr. is less than 60, the overall technical condition of the bridge can be rated as Class 3. For example, a certain bridge through calculation, superstructure, 62 points, Class 3. Substructure, 62 points, Class 3. Bridge deck system, 40 points, Class 4. The overall technical condition score of the bridge is 58.6. Between 40 and 60. Refer to Table 4.154 for queries. The bridge should be Class 4. However, the technical condition ratings of the bridge's superstructure and substructure all are Class 3. Apply this rule. Ultimately, the overall technical condition rating of this bridge is Class 3. 2. During the overall technical condition grade evaluation of the entire bridge, when the score of main components reaches Class 4, or when rated as 5 categories and affecting bridge safety, can be evaluated based on the worst defect condition of bridge main components. For example, a certain bridge's overall technical condition score is 67 points, when 60 is less than or equal to Dr. is less than 80, according to Table 4.15 in the standard. This bridge is evaluated as Class 3. However, considering the midspan of pre-stressed concrete beams in this bridge, crack reaches 0.15 mm, affecting bridge safety, with PCCI superstructure bearing component equals 50. Refer to Table 4.15. The superstructure load-bearing components are evaluated as Class 4. Overall technical condition of the entire bridge. It can also be evaluated as Class 4 based on the worst component. In the end, I will summarize this lesson. First, in the section score calculation, remember to allocate the weight value of missing components, allocate it to other components. Second, overall bridge score, calculated based on weights of the 3 major components. Third, when the evaluation result is obtained, remember to verify evaluation results with 2 special cases. If special condition requirements are met, the evaluation results should be revised. All reasoning must come from observation and experimentation. During our calculation process, cultivate a rigorous attitude towards calculation. Cultivate a rigorous calculation mindset. Be responsible for each step of the problem-solving process and the final results. Rigorously apply each computational rule and every calculation step. Flexibly and correctly apply computational rules. After class, please consider the following questions. A certain bridge's pier foundation is covered by river water and ground. Pier foundation cannot be inspected during detection. How to calculate the evaluation-based score? If the foundation is not scored, is it necessary to allocate the foundation's weight to other components?